In the grand, silent theater of the cosmos, we're the audience, always craning our necks for the next big show. We've built our theories and our rulebooks for how the universe is supposed to behave, writing them based on careful observation, on math, and on generations of knowledge. We know that comets are icy, dusty leftovers from the dawn of our solar system. We know what they're made of, where they come from, and the colors they should glow when the sun's light sets them on fire. We've got it all figured out. Or so we thought. What if I told you that a recent visitor to our cosmic neighborhood showed up wearing a color it shouldn't? And what if that color wasn't just a beautiful fluke, but a blazing signal that our basic understanding of comets, and maybe even the formation of our solar system, is just plain wrong? In late 2025, a comet that wasn't even expected to survive its trip around the sun did exactly that. It came out of the sun's glare not with the familiar green or blue glow of its cousins, but with a bizarre, ethereal golden hue. This isn't just a pretty picture, it's a chemical crime scene, and scientists studying this phantom have found its beauty comes from a shocking absence, a missing ingredient so fundamental it forces us to ask, do we really know where comets come from? This is the story of Comet C, 2025 K1 Atlas, the golden ghost that's rewriting the rules of our cosmic backyard. Before we get just how weird this golden comet is, we need to understand what a times normal times comet looks like. For decades, the go-to image of a comet has been the dirty snowball. First dreamed up by astronomer Fred Whipple back in 1950, this model has been the bedrock of comet science. It pictures a comet as a loosely packed jumble of water ice, frozen gases, dust, and rock, a fossil left over from the formation of the solar system 4.6 billion years ago. These aren't just objects, they're time capsules, preserving the original chemistry of the solar nebula, that vast cloud of gas and dust that birthed the sun and planets. Think of the early solar system as a giant construction site. In the middle, the intense heat of the young sun forged the rocky inner planets, Mercury, Venus, Earth, and Mars. Farther out, beyond the frost line, where it was cold enough for things to freeze, the gas and ice giants formed. But scattered everywhere, like leftover building materials, were trillions of smaller, icy bodies. Those are the comets. Most of them got tossed out to the solar system's coldest, most distant frontiers into two huge reservoirs. The first is the Kuiper Belt, a donut-shaped ring of icy objects just past Neptune. Comets from here tend to have shorter orbits, swinging back into the inner solar system every few decades or centuries. Then, way, way beyond that, lies the Oort cloud. This is an immense, spherical shell of icy bodies that surrounds our solar system, possibly stretching a quarter of the way to the next star. The Oort cloud is the deep freeze, the pristine vault where long-period comets are stored, and it's from this distant realm that Comet C, 2025 K1 Atlas, is thought to have begun its long journey. When one of these comets gets nudged by a passing star or a galactic tide, it can start a slow fall toward the sun that takes millennia. For most of that trip, it's just a dark frozen rock tumbling through space. But as it crosses Jupiter's orbit, the sun starts to wake it up. The ice on its surface begins to sublimate, turning straight from a solid into a gas. This process releases a whole cocktail of frozen gases, the key ingredients for a classic comet show. And this is where the chemistry comes in. The one ingredient we always expect to see is carbon. It's the fourth most abundant element in the universe and a vital building block for life. In the frigid outer solar system where comets form, carbon is locked up in frozen molecules. We expect to find carbon monoxide, CO, and carbon dioxide, CO2, which turn to gas far from the sun and give a comet its first signs of life. We also expect complex organic molecules that, when zapped by sunlight, create other telltale signatures. One of the most famous signatures is diatomic carbon, or C2, two carbon atoms stuck together. When a comet's coma, the fuzzy gas cloud around its core, is bathed in the sun's ultraviolet light, this C2 molecule gets excited and glows with a brilliant, unmistakable green light. It's why so many comets, from Halley to Neowise, have a green head. We also expect to see the signature of cyanogen, Cn, another carbon molecule, which adds a bluish hue. This whole light show, mixed with sunlight bouncing off dust, creates the iconic image of a comet, a bright green head and a long tail. That's the playbook. That's what comets are supposed times to do. A comet without a strong carbon signature would be like a forest without trees. It wouldn't just be weird, it would be a fundamental contradiction. Our story starts not with a bang, but with a faint, unassuming blip of light. On May 24, 2025, a robotic telescope in Chile, part of the Asteroid Terrestrial Impact Last Alert System, or ATLAS, did what it does every night. It scanned the sky. The ATLAS system is our planetary early warning system funded by NASA to find any asteroids that might be headed our way. It's not looking for anything specific, it's looking for times, everything times that moves or changes. That night, the system flagged a new object, designated A11NUL. It was incredibly faint, about 150,000 times dimmer than anything the naked eye can see. It looked like a star, but with a tiny, barely there fuzziness around it, a coma. That was the first clue that it wasn't an asteroid, but a comet waking up. The discovery was confirmed, and it got its official name, C2025, K1 Atlas. Astronomers quickly plotted its path and discovered two critical things. First, this was a dynamically new comet, likely on its very first trip in from the Oort cloud. That made it a priceless scientific target, a pristine sample of the primordial solar system. But the second fact was much more alarming. The comet's path was taking it on a death-defying plunge toward the Sunday. Its perihelion, or closest approach, was set for October 8, 2025, when it would swing just 49 million kilometers from the Sun, well inside the orbit of Mercury. For a loosely packed ball of ice, this is a trial by fire. The smart money was on disintegration. C2025 K1 Atlas was expected to be a short-lived firework that would fizzle out before it even got interesting. Through the summer of 2025, astronomers watched. As it got closer, it brightened and grew a small tail. Early readings hinted that something was off with its chemistry. It seemed low on carbon chain molecules, but it was still faint, and its fate hung in the balance. As September rolled around, it put on a small show, then disappeared into the sun's glare for its dangerous close pass. Weeks went by. The astronomical community held its breath. Had the dirty snowball melted? Then, on October 18, 2025, astronomers found it again. It had survived. Against all odds, it had rounded the Sunday. But the comet that came out wasn't the same one that went in. Amateur astronomer Dan Bartlett, observing from June Lake, California, was one of the first to see it. He pointed his telescope where it should be, and there it was, brighter than before. But it wasn't green anymore. It was glowing with an otherworldly, impossible color. He described it as a red, brown, golden color rarely seen in comets. The doomed comet hadn't just survived, it had transformed, and the mystery of its survival was instantly overshadowed by the mystery of its bizarre new look. The curtain was just going up on the main act. A golden comet. It sounds beautiful, but to a scientist, it's a blaring alarm. Comets have a limited color palette dictated by the cold, hard laws of chemistry. Green from diatomic carbon is common. Blue from ionized carbon monoxide can appear. White and yellow are just reflected sunlight. But gold? That was new. That didn't fit. As images from astronomers flooded the internet, the world saw it, a glowing fuzzy head, maybe with a hint of its old green self at the very core, but trailing a spectacular, long tail that shone with a distinct golden hue. It was stunning, but the beauty was baffling. David Schleicher, an astronomer at Lowell Observatory, quickly aimed his instruments at the visitor. Using spectroscopy breaking down light to read its chemical fingerprint, he confirmed what earlier observations had only hinted at. The signature was bizarre, not because of what was there, but because of what times wasn't asterisk. Schleicher's analysis was clear. All of the carbon-bearing species, including CN, are unusually low. The comet was severely, profoundly depleted of carbon, the very molecules that should be driving its activity and giving it color were practically missing in action. This was the key that unlocked the golden mystery. The typical green glow of a comet happens when sunlight breaks down carbon molecules. With no significant carbon source, there's no vibrant green. The blue glow from carbon monoxide is also gone. So, what's left? Dust. The intense heating during its close pass by the sun had caused the comet to shed a tremendous amount of dust. The golden color, scientists now realize, isn't from glowing gas at all. It's just reflected sunlight, scattering off a massive cloud of dust particles. The specific golden tint comes from the size and makeup of the dust grains, which scatter reddish-yellow light better than other colors, much like how dust in our own atmosphere creates a red sunset. The comet wasn't broadcasting its own light. It was a mirror reflecting the sun's. This explained the color, but it deepened the real mystery. Why was it so carbon poor? This wasn't a minor variation. C 2025 K1 Atlas was one of the most carbon-depleted comets ever seen. Only two others, C 1988 Y Wanyanika and 96P Machholz, are known to be so starved of carbon. This wasn't just an oddball, it was part of an extremely rare class of objects. But the drama wasn't over. In early November 2025, the comet suddenly flared in brightness. Then, on November 10th, observers noticed something catastrophic. The nucleus was breaking apart. What the sun couldn't do in one pass, it had apparently done with thermal stress. The close approach had weakened the comet's core, and now it was falling to pieces. Over the next few days, astronomers watched as the single nucleus split into two, then three, then at least four distinct fragments, each drifting away. The golden comet was dying. This fragmentation, while a destructive end, was a scientific gift. It let astronomers see that the bizarre composition wasn't just skin deep. Each fragment showed the same carbon-poor characteristics, proving the entire body was made of this strange stuff. C 2025 K1 Atlas had given us its final clue. It wasn't a comet that had times lost times its carbon, it was a comet that likely never had much to begin with. And that simple fact has thrown a wrench into our grand model of the solar system. The fact that Comet Atlas is profoundly carbon-poor isn't just a curiosity, it's a crisis. It strikes at the heart of our understanding of where comets form and how our entire solar system was put together. The dirty snowball model is built on the assumption that comets are born in the cold, carbon-rich outer solar system. That assumption is now in serious trouble. Let's go back to that solar system construction site. Our models say that as the solar nebula cooled, different materials froze out at different distances from the hot, young Sunday. Close in, only rock could form. Farther out, beyond the frost line, water could freeze. And way out, in the deep freeze, where the Oort cloud formed, supervolatile things like carbon monoxide were supposed to freeze into ice. This is why we've always believed the outer solar system is packed with carbon. Every comet we've studied up close, like with the Rosetta mission to Comet 67P, has backed this up. They have variations, sure, but they are all fundamentally carbon-rich objects. So the Oort cloud, where Atlas supposedly came from, should be a giant sphere of carbon-rich snowballs. And here's the problem. C 2025 K1 Atlas came from the Oort cloud, yet it has almost no carbon. That's like finding a polar bear in the Sahara. It doesn't belong. This leaves us with two staggering possibilities. Either our understanding of the Oort cloud is wrong, or this comet doesn't come from where we think it does. Let's take the first option. Our model of the early solar system is incomplete. The existence of a carbon-poor comet implies there must have been a region in the solar nebula that was also carbon-poor. But where? Carbon is everywhere. Creating a carbon-free pocket in the nebula would require some unknown and extraordinary process. Maybe the protoplanetary disk wasn't a smooth soup of ingredients, but a lumpy, inconsistent mess. If that's true, the Oort cloud itself might be a grab bag of objects formed in different environments, a chemical zoo we're just now discovering. Atlas could be the first proof of this diversity. Now for the second, even more radical option. C 2025 K1 Atlas isn't really a comet at all. What if it's something else entirely, just masquerading as one? This opens up some wild possibilities. Maybe it's not a primordial object, but a piece of one. Imagine a large dwarf planet way out in the solar system, big enough to have separated into a rocky core and an icy mantle. A massive impact could have shattered this world, sending fragments flying. A chunk from its deep, rocky interior would naturally be poor in the carbon ices found on the surface. This fragment, sent on a long orbit toward the Sun, would act like a comet, but its basic composition would be asteroidal. It would be a rocky wolf in cometary sheep's clothing. The comet's survival and later breakup adds another layer. Its ability to withstand the Sun's heat suggests it might be tougher and more rock-like than a typical fluffy snowball. Yet, its later fragmentation shows it was still fragile. It's both resilient and delicate, another paradox. No matter which theory you prefer, the conclusion is the same. C 2025 K1 Atlas breaks the rules. This one, relatively small object has managed to challenge decades of theory. It forces us to admit our blueprint for the solar system has a glaringly empty page, and this golden comet is the first word written on it. The death of Comet Atlas, shattering into a glittering funeral procession, marks the start of a new scientific mystery. We're now left sifting through the evidence, trying to figure out what this thing really was. The questions it leaves behind are huge. Where did it come from? And what does it tell us about our galaxy? Three major theories have emerged. First is the fragment of a lost world idea. This suggests Atlas isn't a primordial comet, but a piece of a much larger differentiated object that got destroyed. Out in the Kuiper Belt and beyond, we know there are dwarf planets like Pluto. If one of these was smashed by an impact billions of years ago, the debris would be a mix of compositions. A fragment from the deep, rocky interior would be naturally depleted in the carbon-rich ices we associate with comets. This makes Atlas an asteroid in disguise, an exposed planetary core on a comet's orbit. This theory is appealing because it neatly explains the carbon deficiency and its tough but fragile nature. The second theory is the alien birthplace hypothesis. This suggests Atlas Times is times a primordial comet, but one that formed in a part of our own solar nebula we didn't know existed, a carbon-poor pocket. This forces us to redraw the chemical map of the early solar system, suggesting it was clumpy and uneven. Perhaps the region where Atlas formed was unusually hot, or it was blasted by radiation from a nearby star that destroyed carbon molecules. If this is right, the Oort cloud is a diverse collection of objects, and Atlas is our first look at a whole new class of comet. Finally, there's the most exotic possibility, the interstellar imposter theory. We know objects from other star systems pass through ours. We've seen Oumuamua and 2I, Borisov, and, just to make things confusing, another object discovered by the same survey, 3I Atlas, is a confirmed interstellar comet, but it's a completely different object from our Golden Comet. What if C 2025 K1 Atlas is also from another star system, captured into an orbit around our Sun long ago? Other solar systems could easily have different chemical makeups. A comet from a carbon-poor system would look bizarre to us, but be perfectly normal back home. This is the hardest theory to prove, but if true, Atlas would be a priceless alien artifact, our first real sample of the building blocks of worlds beyond our own. The story of Comet Atlas is a perfect example of how a single observation can challenge everything we think we know, and this happens all the time in astronomy. If you find these cosmic mysteries as fascinating as I do, and you want to hear about the next discovery that could rewrite our textbooks, make sure you subscribe and hit that notification bell. The universe is full of secrets, and together, we're going to keep uncovering them, from a faint smudge of light to a celestial ghost glowing in impossible gold. The journey of Comet C 2025 K1 Atlas was extraordinary. It survived a fiery encounter it shouldn't have and emerged transformed not by adding something, but by revealing a profound absence. Its lack of carbon, the very element that gives comets their signature look, has forced us into a deep uncertainty about our own solar system. This single object, now a silent, drifting cloud of golden dust, has become a crossroads. Does it point to an unknown, carbon-poor region of our own primordial past? Is it a piece of a long-lost world, telling a story of ancient violence? Or is it an alien, an interstellar wanderer captured by our sun, offering a precious sample from a distant star? We don't have the answers yet. The fragments of Atlas are now too faint to study their spectacular performance over, but they've left behind a legacy of questions. This comet is a powerful and humbling reminder that the cosmos doesn't care about our expectations. For every rule we write, the universe seems to have an exception waiting in the wings. The story of science isn't a straight line. It's a winding path of mystery, surprise, and constant revision. And in a silent, golden streak across our sky, Comet Atlas just reminded us that sometimes the most profound discoveries begin when we look at what we've found and admit it's time to rip up the rule book and start again.